Hello everybody, this is Chad Williams, and today I'm going to walk you through Lab 6 of Psych 300B. This is a continuation of Lab 5. So remember last week we ran a Levine's test and then an ANOVA. Now today what we're going to do is we're going to probe that ANOVA further. So we found that there were some differences somewhere, but we're going to use planned comparisons and post-hoc comparisons to figure out where those differences are. So we're going to use a Duns test for our planned comparison. Then we're going to use a 2-key test for our post-hoc comparisons. So what's familiar to you is probably most of this script because we just took last week's script and added on to it. We did remove some things to make it a little bit simpler, but this first 2/3 of it should be familiar to you, and this is all that's new here. So we're going to walk through the whole thing, but just really quickly until we get to the Duns test. So as usual, we need to set our working directory. So I'm going to choose directory. Today we do have one additional thing though. This file here called dunstest.r. Within this file is a function called dunstest. Now we found out that all the Duns tests that are already incorporated in R actually do it wrong. So Dr. Medler created his own function. We're not going to walk through this function today, we're just going to use it. So we just need to make sure that this function, this file here, is in the same folder as our data. So if you don't have this file, go to Brightspaces and get it, and then put it in the same folder as your data. So I'm going to open that here, and then I'm going to load my data set right there. Easy enough. Now we have to install any packages that we're missing. So we had the car package last week for our Levine's test. This week we're going to use the Mosaic package to do the 2-key HSD test. So let's run those quick. Then you see that we need to load them into our libraries right here. There we go. Now we have car and Mosaic. Now this is a little bit different. What it's doing is basically running this script that Dr. Medler created. That's going to give us a function. So if I run this, you'll see now that the function dunstest is ready for use. So again, I'm going to go through this pretty quickly because we did do this last week. We need to change our independent variable into a factor here. So if I run that, now it's a factor. And then we're going to run our Levine's test again. And there we go. We see that we've met the homogeneity of variance assumption. Now we're going to look at our ANOVA test and see that we have a significant main effect here. Great. So I'm not going to walk you through these things again because we did this last week. So now what we have is the Duns test and the 2-key HSD. Remember the Duns test is a planned comparison, and you could do up to k-1 planned comparisons. So here we have 4 different groups. So what we're going to do is we're going to have k-1, which means up to 3 comparisons. Now you could do any from 0 to 3, but we're asking you today to just do 3 because we want all the assignments to come in with the same type of information. So here we have 3 different examples of what comparisons we can do. And I'll walk you through this in just a moment. It looks a little bit confusing, but that's okay. But I do want to show you the Duns test that Dr. Medler made. So we built it in the sense that it's looking very similar to these other tests or other functions we've been using. So we have our independent variable and our dependent variable here, just like we did there. And then we have our data here as well, just like there. The only difference is we have this additional comparisons parameter here, which we're going to define right here. Now that we're about to run things, and really I should have told you before we ran the ANOVA and stuff, I want to remind you that I'm looking at time of day self as my dependent variable here, but you're not. You're looking at hours self. So make sure that you're changing these again so that they're hours self instead of time of day self, and same thing with here. You want to make sure that you're looking at the right analysis, and I'm using a different column of data in our data set. And just to remind us what our data set looks like, here's our social media preferences. We have our hours self, and again, this is what you're going to be testing on. And then what I'm testing on is time of day self here. Great. So what does this mean? So we have 3 different comparisons here, and that's the first one, that's the second one, and that's the third one. Okay, so we have 4 different numbers here. 1, -1, 0, and 0. And each place corresponds to one of our groups, okay? So let's look at our data. and see what those groups are. So the first number is for Facebook, the second number is for Instagram, the third number is for Twitter, and the fourth number is for TikTok. So again, this one is Facebook, then Instagram, then Twitter, then TikTok. Another way of looking at those 4 different variables without actually jumping into your data is to use the levels function. So I'm going to do it down here. So if I go levels, and then I'm going to put in first my data frame, and then $, the variable of interest or the column of interest. If I hit enter, there is my list of 4 things. So again, this first one is going to correspond to Facebook. The second one is corresponding to Instagram. The third one is corresponding to TikTok. And then the fourth one is corresponding to Twitter. And that's for our first comparison. Then we could do the same one for the second comparison where they're in the same order. So this one's Facebook, that one's Instagram, that one's TikTok, and that one's Twitter, and so forth. Now, what do these numbers mean? Well, the first thing to note is the zeros. The zeros mean they're not going to be included in this comparison. So if we look at all of these, the last 2 are zeros, which means we're not going to be looking at TikTok and we're not going to be looking at Twitter in this comparison. What we are going to be looking at is 1 and then -1, which is Facebook, and then Instagram. So one of them has to be +1 and one of them has to be -1. You could switch them, it doesn't matter. That just changes the direction. So it's either Facebook minus Instagram or Instagram minus Facebook. So we can check this comparison as another example. So again, our zeros indicate that they're not going to be part of this comparison. So the first one, Facebook's not going to be part of this comparison, and neither is Twitter. But Instagram and TikTok are, because they're the ones that are 1 and -1. And then finally, we can look at our third comparison here, and so we see the first 2, so Facebook and Instagram are not being considered, but the second or the last 2 are, so TikTok versus Twitter. Now these are 3 examples of what you can do. So these are 3 comparisons that we've chose as an example, and you can run these and move on, and that's okay. But you can also feel free to change these up. For example, what if we were interested in Facebook versus Twitter? So what we're not interested in there is Instagram and TikTok. So let's make sure those 2 are 0. But then Facebook is 1. Then we can make Twitter, so that last one, -1. Now what this does is it compares our Facebook group to our Twitter group. And then it ignores our Instagram and TikTok. I'm going to just put it back to what it was before, so that way it continuously matches your script. But that's just a way you can choose different contrasts if you're interested in different contrasts. But here all I'm doing is Facebook versus Instagram, then Instagram versus TikTok, then TikTok versus Twitter. So since we have these comparisons, that's going to go right here. And what we're going to do is run all these. Or let's start with the comparisons, and then we'll run the Duns test. And you see that we get a result, and it's in a table here. Then if we print it, there we go. The first thing we see is our comparison, so Facebook versus Instagram. And that corresponds to this one here. So that's Facebook versus Instagram. The first column after that is our mean differences. So between these 2 groups, there is a 1.5 mean difference. Then we get our Duns t-value, then our adjusted p-value. Now it's adjusted because we've adjusted it for multiple comparisons here. Okay, so these are the p-values you're going to report for Duns test. They're already adjusted for us. So we see that this Facebook versus Instagram results in non-significant differences. So we can look at Instagram versus TikTok. The mean difference is -1.9. So that's just because the TikTok has a higher value than the Instagram. And we see our t-value here, then we see 0.0156. With an alpha value of 0.05, that means this one is significant. So we find a significant difference between Instagram and TikTok. Then we also see our third comparison here, which is TikTok minus Twitter, or versus Twitter, and we see no significant differences again. So now we've run our 3 planned comparisons. It's time to run our Tukey HSD. Now one thing to point out is that this is going to run all 6 different pairs of tests that you can run. So let's look at that now. So if I run this, we get our results. We can pop it open and start looking through it, but as we always do, Let's just run that last line of code to get it all printed out nicely for us. So now we see a very similar kind of pattern here where we have our comparisons, so Instagram versus Facebook, and then Twitter versus Facebook, Twitter versus TikTok, and so forth. We have our mean differences. So what we'll notice is Instagram versus Facebook had a difference of 1.5. Now it still has a difference of 1.5. See, now it's Instagram minus Twitter, doesn't matter. So it's negative 1.5 instead of positive 1.5. We're not going to worry about the lower and upper limits here, but we are just going to go right over to the p-value that's adjusted. So the first thing I want to point out is Instagram versus TikTok. So we found 0.0156 as our p-value when we ran the Duns test. And then here we could see that it's different. So we have a higher p-value here. And that's because the Duns test is more powerful because it's a planned comparison. But do remember, because we already reported these as planned comparisons, we're not going to re-report them as post-hocs now. We're going to ignore the ones that we already ran as a planned comparison, and then we're going to use this just for the ones that we haven't done yet. Okay? So make sure you're reporting only the 3 that you haven't reported in your planned comparisons here. Well, good luck.